In chemistry, you need to prepare yourself for some very long numbers. And I'm not just talking about big numbers, although we have a lot of those in chemistry. You also need to prepare yourself to deal with extremely small numbers. In fact, chemistry is like a quest to find out how small can be. Let me give you an example of what I mean. Consider this piece of aluminum foil right here. Now, aluminum is an element. So this sample consists of aluminum atoms, the smallest parts of aluminum that you can have. What if I were to ask you how many aluminum atoms are in this small sample of aluminum foil? Well, the answer might surprise you. The answer is 829 quintillion atoms. How big is a quintillion anyways? Let me give you an idea. It's that many atoms. It's a lot of atoms. Now, can you imagine what it would be like trying to get through your homework when all of your answers look like this? Do you think it's possible you might make some careless mistakes and skip a zero or add an extra zero in there? It could happen. Now, there's another deal with numbers like aluminum. What if I asked you how much mass, how many grams, are in just one single atom that's in this sample? Well, in that case, you got a really small number. Consider this. One atom of aluminum has a mass that looks like this. I ran out of room. Grams. Not a lot of grams, but that is a lot of zeros. So in science, we have a way to deal with this, and it's scientific notation. And you need to know how to use scientific notation backwards and forwards. We will use it a lot. And answers in the back of the book might be in scientific notation, and you're going to have to be able to put your answer in scientific notation to compare. So, how does scientific notation work? Well, in general, all scientific notation numbers look like this. They are written as the product of two numbers. That means two numbers are multiplied. One is called the coefficient. The coefficient is always a number less than or equal to 1, and it's always less than 10. I'm sorry, greater than or equal to 1 and less than 10. In other words, in scientific notation, we put the decimal after the first non-zero. Now the coefficient will always be raised to some power of 10. So, let's see how we can convert these numbers, these large numbers that we have, into scientific notation. So, we'll take the 829 quintillion first. Our goal, remember, is to create a coefficient with the decimal after the first non-zero. And in this number, the first non-zero is 8. We want our decimal to be right here. Now, we can't change what this number is worth. So if you just put the decimal there, it's not the same number anymore. We need to tell people who look at this number that that decimal has been moved. In fact, it's been moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It's been moved 20 places. To get around writing all those zeros, what we'll do is we'll write 800.29 coefficient times 10, and we need to multiply it by 10 20 times, because every time we move the decimal was a multiple of 10. What this is saying is, take this number, 8.29, and make sure you understand that this decimal needs to go 20 places that way. 20 places that make this number bigger. Now, consider this number. This is the mass of one atom of aluminum, and we said that we had 22 zeros to get to here, 23 zeros to get behind the first non-zero. So, 4.49 brings this decimal 23 places over behind the first non-zero. Now in this case, if I were to multiply by factors of 10, I would really be making this number bigger. And I want to make this number smaller. Really, we're dividing by 10. And a negative exponent is the same thing as the reciprocal, another 1 over, or divide by 10. That's the number of grams in one atom. Of aluminum. So let's take it the other way. What if you're given a number in scientific notation and you need to see that number in standard notation? Let's take a number like 6.81 times 10 to the fourth power. We want to put this in regular notation. When I look at this exponent, positive exponent tells me this number is really bigger than 6.81. And I need to move the decimal in the direction that multiplies and makes this number bigger. So I need this decimal to move 4 places. Times 10 once, times 10 twice, and then times 10 2 more times. I'll have to add zeros for those placeholders. 6, there's, move the decimal over once, move the decimal over twice, 3 times, 4 times. So 68,100 is the same as 6.81 times 10 to the fourth power. What do you do when your exponent is negative? Well, first of all, you should recognize that an exponent that is negative is telling you that this number is smaller than 3.29. And a couple ways you can think of it as negative exponents are going to indicate that this is a number less than 1. It's going to be a decimal. Another thing, if you see this negative exponent, imagine that it is an arrow and it's pointing that way. And that's telling you you're going to need to move the decimal that way to make this number smaller. We need to move it 5 places. So here's the 3, 9, 2. My decimal was here after the 3. I'm going to move it 5 places. 1, put a placeholder 2, put a placeholder 3, 4, 5. So 0.0000392 is that number in standard form. Okay, now on my website, if you go to mrsexton.com and you check out Unit 1, scroll down to Scientific Notation, there is an infographic. It looks like this. It's a nice one-stop shop for all your studying needs. A good place to review and make sure you understand scientific notation. And if not, come to me with your questions. Now, one more thing that I want to mention here, which is your calculator is your best friend in chemistry. And you need a calculator friend in chemistry. The calculator will make your life easier if you know how to use it. And scientific notation is frequently entered incorrectly on the calculator. So, if we have a number, 6.02 times 10 to the 23rd power. That's a famous number in chemistry, known as Avogadro's number. We'll get to there. If you were going to enter this in on your calculator, you need to understand that you don't enter 6.02 and then you don't hit the times button, you don't type 10, and you don't go to the 23rd power. There's a special button on your calculator, and what that one button does is it goes times 10 to the. It's your times 10 to the button. So, look here at this calculator. Some are different. If I wanted to enter in that number, I would go 6.02. Now here's the special button. In this calculator, it's this one that says EE right here. And when I push that button, it's like I'm writing times 10 to the. So I've typed in my 6.02 times 10 to the. And now all I have to do is type in 23. And there you go. Fly likes it. Other calculators look a little different. For instance, this one, the special times 10 to the button is right here, EXP. Typically, you'll see EXP or EE for exponential expression. And that tells you that that's your scientific notation button. Now, there's other calculators. They have the button hidden in different places, and if you're not sure where that is, you can look in your calculator manual or bring it to me. I've seen most of them, and I'll help you make that work. All right, guys, good luck.